So in this video, I am going to show you how you can use this ARIMA modeling for a real world dataset. So for this example, I have downloaded the Bitcoin value variation from 2014 to 2020 June. So if you run this, the particular dataset has the Bitcoin value starting from 2014 January to all the way to 2021 June. So let's first of all let's plot this dataset and see how the dataset is arranged. So we'll give the X label as the time, and then the Y label, which is the Bitcoin value, and finally we can give a title also. So we'll name it as change of Bitcoin value. So now let's run this and see how the Bitcoin value changed over time. So if you look at this initially for a long period of time with almost at the same level. However, after 2017 it gradually started to rise, and by the end of the 2021 it reached to a maximum value and also fell after 2021. So as I have mentioned in the previous videos, before we conduct this any classical time series analysis, we have to check whether our dataset is stationary or non-stationary. So first of all, we'll check stationary of our time series dataset. So for that, I'm going to call the idf.test function and call this particular time series object that we have created, and we'll run this and see whether our dataset is stationary or not. So you can clearly see the p-value is not statistically significant, which means we have to agree with the null hypothesis, which we can determine that the dataset is non-stationary. Therefore, before conduct any analysis further, we have to convert this dataset into a stationary dataset. So we'll do the differencing method for that. However, before we do that, we have to check whether the number of differentiation required to stationarize the dataset. Therefore, in order to do that, we can call the ndiffs function and call this particular time series dataset. So according to that, you can see it requires one differencing. We can conduct the differencing one time and see and check whether the data turn into a stationary data set. So we can call the diff function, and after that we can again call this ADF test and check whether the p-value is statistically significant. So now you can see the p-value is smaller than the printed p-value, and also it mentioned it has 0.01, less than 0.01, which means our dataset is now statistically significant. Therefore, we can agree with the alternate hypothesis where our dataset is stationary. Now we can call the ARIMA function and conduct the ARIMA modeling. So first of all, I create a new variable and I'll call auto.arima function. So in this way we can conduct the ARIMA analysis, and if you print this, get the output, you can get all the types of coefficients related to the ARIMA for the ARIMA modeling parameters. Then the next step is to forecast our dataset. So for that we have to call the forecast function. So for that I am going to create another new variable and call the forecast function. So for that I will use this particular result from the ARIMA modeling and specify as the 12 as the period. So in here I am mentioning that I am going to forecast the values for the next 12 months or the next time cycles. Since our original data set is a monthly data set, if we specify 12 in here, it will calculate the data set forecast values for the next 12 months. So we can also call the autoplot function and check whether how our data is predicted for the next 12 months. So we can create a y label also. So I'll name it as the predicted Bitcoin value as the GG title. So let's run this chunk of codes and see how our forecast is appear. So there is a small error in here. Let's see what's happening. So the plus mark is missing here. I think that's the reason. When you can run this again. So if you zoom in, now you can see this part is values, and in this way we can conduct ARIMA modeling and predict the future values or forecast future values based on the previous data sets. So that's it from this video. See you in the next video.